And you can have access to it through my website, which I will share at the end of this presentation. So what we're going to be going over today is one of the pillars within the preparations for the CMRP exam. And this is on manufacturing process reliability. While we're not going to have time to go through all of the categories within it, we are going to dip through some of the popular ones and some of the ones that may cause some confusion, and also touch on the different areas within that pillar and how they support the different pillars within the body of knowledge of that society and maintenance reliability profession. And we can get started. Just want to arrange things here so I can. So just as a clarification, it doesn't matter see how many times I do this. I seem to always have a problem sharing the screen on it, and I just stopped. So like I said in the intro, I'm Mary W. Schultz, and I'm going to be going over one of the pillars, process manufacturing reliability or manufacturing process. What I'm going to be going over is one. What you're going to learn is what's the benefit of getting a CMRP? Some of the facts, or some of the debunks things about the CMRP. Understand what's included in a manufacturing process reliability, and think about how you can debunk questions for the CMRP. There's different ways you can look at the questions. They are a multiple choice, and the ways you can pull out some of the ways that can be outliers or can be removed. A couple examples and analysis of some of the questions, and how to build a strategy for taking your. Now, if everyone's going to take in the CMRP, you will be asked to take a non-disclosure agreement. And that is saying that I'm not supplying you the answers, or you're not going to be sharing the answers with it, because at the end of it, we want to have a governance around the need for that the accolades of having a CMRP hold true. And that's why we do sign a non-disclosure agreement. So nothing you will be seeing here today violates that. However, we do have some CMRP-like questions that I'm going to be sharing that I've created through my simulate. I should disclose that if there's anything going on in the chat, I'm not going to be able to check that for the time being. So you may have to have a question, come off mute and share that with me, or hold it till the first break or the TM. So why obtain a maintenance certification? There are others out there. One, it's a globalized recognition of best practice. Whether you're part of the CMRP, the EP, MXC, the IAM, the AM Council, or the EFNMS, they all have similar like practices or best practices that we hold. For me, I'm a CMRP, so what I'm going over is what I've used and learned to get my certification and what I share in the practices in teaching others. But to get that, you also have demonstrated a level of knowledge. You've had the experience to come into the industrial of maintenance and understanding. It helps you validate the knowledge and expertise specific maintenance field. It also can unlock doors. Hopefully, most of you, this can lead to increase in revenue, change in position, or in a lot of cases, it is a prerequisite for some of these hiring positions that you may be interested in, but also feel pride in your position, and it adds confidence to your current role, knowing that you are experienced and familiar with some of the best practices that go within maintenance. Just a little bit about myself. I'm A.W. Schultz. I'm the principal consultant. I work with a lot of factory leaders. I focus on work management, a lot in the realm of planning and scheduling, but I also do a lot of training on certified maintenance reliability professionals. I've got a couple of books out there that are on specific to the CMRP, but also on understanding work management. And one of is the toolbox of just overall maintenance reliability. I encourage you to check them out. They do hold a lot of the knowledge that I'm going to be sharing with you today, but like I say, it can't be all explained in a short 2-hour training session. So why do we even do maintenance reliability? Well, it goes back to how do you manage, and there's different maintenance strategies that evolve from managing assets over the years. And now you may debate some of these timelines on it, but the important thing to know is that it has progressed. It has had an evolution to what we currently have, starting with the reactive mode, back when automation became somewhat popular and became an idea that we can't just wait for things to break to fix them. Moving on to preventive, this is still hold true today. There's still planned maintenance, scheduling overhaul. Society saw a value in the industries to have plans in place to make themselves reliable. We made it, we know what's going to be made, and then it became more predictable. Computers and then it becomes predictable. This is your condition-based, your vibration monitoring, your design for reliability and maintainability. More technology and IT is in logical decision-making, pulling back into understanding what a failure mode effects analysis can have value in determining your new processes or evaluating your assets on it. And then while RCM was actually introduced back in the 1960s by Boeing, the correlation between reliability-centered maintenance and total productive maintenance have had integration that's been evolving for the last 20 years. If you think about asset management, a lot of times asset management also includes the people that are involved. And that's where TPM plays that role on creating autonomy. It's a risk-based approach. It's a quantitative risk assessment using simulation software, applying digital twins, Internet of Things, understanding what the net present value calculation, determining what the risks are, and making an assessment of when do we run to failure or when do we have predictive measures. So today, we're just talking about one of the 5, manufacturing process reliability. They're called pillars because they hold all of what it is for maintenance reliability, whether it's how the business and the management is ran, to how the equipment is used, how detection is used to drive business and organization's results, how leadership plays a part in it, and then how does the work get done? Seeing the value, and there's been more of a push within the SMRP to incorporate more understanding of what is the ISO. As we come on a global level, having standardization plays a crucial role in how work is getting done today. So as you're going through getting your CMRP, we'll find similarities about what are the expectations of an ISO. We're going to be talking about 3 of them today, putting a lot of attention around the 55,000 as it's gained a lot of headwind in what is being asked of organizations. To get organized though, start with the first one, is the 14.2.2. This is about how data is collected, how data is dispersed. The collection of reliability and maintenance data in the standard format for the equipment. It could be petroleum, natural gas, petrochemical industries. It's understanding the cycles of the equipment. But as you do it, also understanding we've got a common language that throughout the different industries, when we talk about breakdowns, or we talk about reliability, we talk about some of the other terms that are prevalent in your organization are also used in another industry, and how that data is exchanged between. When we talk about overall equipment effect, having standardization plays both an important role in understanding how we're running, but also plays a role in how the financials are fed in through how output is being delivered. The fundamental of asset management consists of 3 components within the ISO 55000, beginning with what is the overview of it, principles, and the terminology. It addresses the strategic and tactical management of the assets with an emphasis on the value derived from the assets and the management of the risk. The ISO 55001 requirements of what feeds into them. And then if you look at the O2, this is kind of peeling the onion back about the details of it. And you can see it's been updated since 2018 of the guidelines for the application. As of the end of 2020, over 300 organizations have formally implemented an ISO 55. It's been growing over the years, and it only continues to grow as organizations see the value of having a prestige of saying they've got standardization, both from their customer standpoint, but as a liability standpoint within their industry. Within the 55,000, it identifies 4 fundamental asset management, or you can remember saying it's value. The value, the alignment, leadership, and the assurance. The value assists to provide value to the organizations and its stakeholders. Stakeholders are all those that essentially they care about within all of the organization. It's defined as the organization and its stakeholders differ from the organization to organization. So while we want standardization, different industries operate different, but knowing that we've got a blueprint that gives a guided standpoint, we can see where those likenesses. The second is alignment. The objectives into technical and financial decisions, planning, the activities. This can lead into all levels and departments of the organization. The technical, the financial, operations decisions or achievements through an asset management objective. The alignment also implies organizations' wide planning and data-driven decision-making. The point is we don't want organizations to be making decisions on the side. We want to be shared amongst all departments and organizations. And then, of course, asset management leadership plays a part of it. That's where the decisions are made, go, no goes, therefore. Leadership workplace culture is determinant of the realization of value. It's essential, the leadership at all levels by fully engaging the process and ensure. And the last is ensure. This is to fill the requirement purpose. Implementing asset management management principle provides assurance that the assets are providing the required value for the organization. It involves implementing processes that connect the assets to the organization's objective across all life cycle stages and the process for monitoring and continual improvement. As an overview, the ISO 55000 provides principles and terminologies and the expected benefits from adapting asset management. It explains what to do, not how to do it. It allows organizations to self-declare conformity. It's important for the reliability and maintenance professionals to realize that they will have to partner with the entire organization to develop proactive asset management program. And it drives the greatest asset utilization and a return on the net asset and lowering the overall total cost. The ISO 55000 describes an asset management system as a management system for managing the asset. It's a lot of word management. It takes a top-down approach, something to realize it starts with leadership and it's funneled through it. It's descriptive rather than prescriptive, and organizations can benefit greatly following the implementation. Multiple case studies have been done that have shown how they've benefited from having a standardized program. The last of the ISOs that I'm going to talk about is the 45001. This is more on the org health. If the 55,000 you can look at it encompasses, it takes different ISO standards and it asks for the applications of it, the process of it brought into it. So you might see a 55,000, but you would also see the processes in place for the org and health of the organization. And the idea is in this one, you continually have improvements to the process. You're fulfilling the legal requirement and you're meeting the objectives. As I go through this, I'm just going to take a little. So I'm going to go a little bit deeper and understand the overall equipment effect on it. You may or may not know, there's three things that feed into that. First is the availability, performance rate, quality rate. It gives you the overall equipment. Now you can't talk about reliability without giving some reference to what this is. Now this plays a part when you talk about the ISO 55000 because it's saying we need a standardized process. And I'm going to be sharing to you what the Society of Maintenance Reliability Professionals Body of Knowledge defines. And often I refer to this when asked when you're defining what is availability and how you define performance. One thing to know is that OEEs actually was developed in the mid 1990s. So a lot of us, this is in our lifetime. And if you think about the earlier slide when we talked about the different evolutions of the industries, there was a point when reactive work and planned work, we necessarily didn't know how the equipments were performing. And certainly if you didn't have standardization to it, you wouldn't have a good grasp on how well another industry or industry could be to knock out some of these terminology. And firstly, understanding what availability is understanding the runtime and is defined as the total production time that a machine is running or producing parts. The setup. This could be changeover, SMED. This is the time that the machine needs to get ready before the first good part produced. And then downtime. This is the period the machine is not available to produce due to maintenance or breakdown. Now, doing maintenance is often is considered an investment to prevent breakdowns and begin to question what is the reliability of, so understanding what that availability. And the last one, the terminology is the total. This is the combination of runtime, downtime, and setup. In the performance category, this is understanding the actual speed. Often this is a speed that's budgeted, flow rates or counts per minute, understanding where your bottleneck is. So what is the maximum planned production that you can produce. The normal speed is defined as the total number of parts, good and bad, that is produced on the machine. The quality aspect, this is the input account of parts produced to manufacturing specific specifications on the machine. So this would take into account all good sellable product that are produced. If a product was determined to put on hold, that would be excluded. So going back to the math, in availability, you could take two categories on. Downtime, which is defined as equipment losing its capability to function as designed, and it all could be breakdown. Stoppage is longer than 10 minutes. Setup and adjustments, the things get going, they have to change things and move it around. Or it can also include planned down. So if you looked at an example, if a processing factory has the capability of producing 168 hours a week. Those who know that's how many hours there are in a week, 24 hours a day. This would be the availability of that equipment. However, if the factory was only able to produce, say, 100.8 hours a week, its availability would be 60%. So we define that the availability of that equipment as 60. So we've got one category. So what about the performance rate? The losses to this can be idling or cycle time, or minor stoppages or machine idling. Now, factory's performance is by knowing what the budget rate or speed of the line or the factory and the actual speed or the rate that it is running. If a factory has determined that it has the capability to produce a predetermined cycles, widgets, or tools, the adjustment speed is actually produced. So in this case, for example, if a line or factory is normally budget for a speed of, we're using simple math, 1,000, these could be widgets, and it actually only produces 900, well, that performance is now 90%. So solving the third is the quality of it. Now, this may seem self-evident, but to think about is this rate includes products that could be reworked or whole or it could be startup yields that are, less than 99%. In the example, if a line or factory produces 8,000 of something product, but only I put 7,999 are good, sellable, then the quality is 98.88% quality. So if you take those relatively common, simple numbers and you feed them back into the overall equipment effect, we can determine how effective it is, the reliability of it. And multiplying these three together, 60 by 90 by 99%, the OEE of that particular example, just under 60. And these are just the numbers supporting where we just talked. But at the end, you had 60% OEE. When the three come together, an instant snapshot of the reliability of that factory or the equipment is determined. In this particular case, is that good or bad? Well, a lot of it is in organization, you create a plan or a budget of what you expect. It's called maintenance reliability for a reason, because if you apply maintenance to it, the reliability should increase. And understanding where the reliability is helps you to pinpoint where you can go after something. And that's what's so good about how the 5 pillars of the SMRP are set up, is that while they're not silos, they are pillars holding each other up, that they need each other to know about. So we talk about manufacturing reliability. To improve it, we need to pull from equipment reliability to apply some of those tools that are applied. And the same holds true for the leadership of it, and understanding the business portion, and then the work management, how the stuff. So this next portion we're going to look at is what process tracking indicates. It is important to have a grasp on the difference between what are leading and lagging indicators, often used conjunction as the results of the other. Leading indicators measure the performance before the process results show a particular pattern or trend. Often they're used as a tool to indicate where problems are happening before they happen. Lagging indicators are the after results. To think about this is that the leadings fill into the lag. Leading indicators is created into 3 different measures: preventive controls of the effectiveness, performance, and the compliance. The lagging of it is to have measures out there, and I'll show you some of also that show what is the finished products or the overall, often these can be called KPIs of the organization or business. And then the idea is you understand the controls that can lead to the governance and build a PDCA culture, which is a plan, do, check, act. So when you know what's affecting the leading, or pull back on that. If you understand what's driving the lagging, you pull back to see what's driving it in the leading, and you could risk avert. Here's some examples of leading indicators. And many of you probably have heard these before. Mean time before failures, mean time to repair, planned maintenance, compliance and completion, how well it was done, how well are you doing? Are you reducing breakdown? Are they rising? What's the rate reduction? What are the quality issues? We talked about OEE. These are some of the things that lagging indicators measure the performance after the business or process has completed the product or service. One of the hints, that's when you remember it's lagging. It's always after. Things that examples could be, what is the units produced, the OEE, return on investments, return on assets, or the cost of goods. Now, leading actions that can drive these out could be a root cause analysis, understanding control limits, 6 Sigma. An example might be a fishbone diagram of trying to find root cause. Leading actions. Now, this is the way to look at it: is this, we don't know what the problem is, but we're going to look to be proactive and going after some, be an FMEA or applying total productive maintenance to an organization. And that's how you look at it to drive some of the results from what is leading to overall what is a lagging. I'm going to go through one more section, and then we'll take a short break. I'm going to talk about lean. Now, lean is a concept of making what is right when it's right, and having the process and principles in practice. And just think about having perfect first-time quality. It's a quest. It's an aspirational goal for 0 defects and revealing solving problems at the source. Now, there's a much of a different tools that you can pull into them. And we're not going to get into a lot of those today, but I will highlight some of those as you can prepare for some of the best practices that are used in some of them. It is about continuous improvement, reducing cost, improving quality, increasing productivity, and it's also information sharing. Pull process. Products are pulled from the consumer's end, not pushed from the production. I've got 2 kids, and I can tell you that while I talk about pull system, in the morning when I'm trying to get them to school, I'm in a push system. I'm trying to get them out the door. Now, who's to say that having incentives on the back end could turn that push into a pull system? But to understand is that a pull system is more predictable than a push system. Often a push system is firefighting and a reactive. And today, producing different mixes or greater diversity of products quick and also without sacrificing efficiency at a low volume of production. We want to be flexible, building and maintaining a long-term relationship with suppliers through collaboration of risk share, cost sharing, information sharing, having the flexibility, adaptability to be able to transform when needed is also a requirement. And then probably one that makes more sense when you call it lean is minimize the waste, making sure we don't add any value added or safety nets, maximizing the use of resources. It could be capital, people, or it could be land. So within lean, there's essentially 8 types of waste. And the value is lean practice, you're consistently trying to drive those out to an aspirational zero. There's 8 types, and any of you that have been in the industry for a while know that there actually was only 7 up to a few years. And we'll talk about that. Lean manufacturing is a management philosophy on reducing this. And I'll try to go through these relatively quick, but I do want to give you some examples because you can see where waste is added that you may not have thought in the past. Transportation is the movement of people, tools, inventory, equipment, or products furthering than that is necessary. Excessive movements of materials can lead to product damage or defect. Additionally, excessive movements of people and equipment can lead to unnecessary work and a greater wear and tear or exhaustion on the assets or the equipment. Different ways you can address that: countermeasures to transportation, U-shaped production lines, flows between processes, and not overproducing work. Inventory. Oftentimes, it's difficult to think about excessive inventory. You think about accounting, inventory is seen as an asset. Oftentimes, suppliers give discount for bulk purchases, but having more inventory than necessary to sustain a steady flow of work can lead to problems, including product defects or damaged material, greater lead time in the production process, or inefficient allocation of capital, and problems being hidden away in the inventory. Having too much inventory can often be seen as having a push system. And the ways you counteract making sure you have supplies is having a lot of inventory. Or in a pull system, you want to keep it as low as possible. So excess inventory can be caused by overpurchasing, overproducing, WIP, producing more products than the customer needs, too much finished product, extra material. It's adding more than what ideas, purchasing raw materials only when needed. That creates a pull system, reducing your buffers, creating a query system. Motion. This is unnecessary movement of people, equipment, looking at the safety of it. Countermeasures can be a work area organized, offering 5S process, placing equipment near the production locations, material in ergonomic position, making it easier for the individuals that run the waiting. The waste of waiting includes people waiting on material or equipment, idle equipment. The waiting time is often caused by unevenness in the production stations and can result in excess inventory or over. Countermeasures are having a continuous flow, single piece flow, leveling out the workload, or developing flexible multi-skilled. Over processing. Now, this refers to doing more work and adding more components or having more steps in a product or service than is required by the customer. In manufacturing, this could include using a higher precision equipment than necessary, using components with capacities beyond what is required or needed, running more analysis than is needed, over-engineering a solution, adjusting a component after it's already been installed, and having more functionalities in the product than what is being asked. The idea is always have the customer. Overproduction occurs when manufacturing product or element of the product before it is being asked or required. It may be tempting to produce as many products as possible when there is idle work or equipment. However, producing product that is needed under that just-in-time philosophy, not a just-in-case. So I look at doing a value stream map, understanding what the takt times are for the production cycles, finding ways to reduce setup time, and creating a pulse and defects. That's pretty self-explanatory. Product is not fit for, it's not sellable to their customers. This could also be for reworking or scrapping them. Tactics could this determine what the frequency of the defects are. After a break, we're going to talk about Six Sigma and how Lean and Six Sigma have a relationship and how they're used in conjunction with, and design a process to determine admiralty. Maybe you need to redesign the process. What is the standardization of work? Pulls back to the 55,000. And the last one, and the more new effect to it, is skills on non-utilized talent. Even though it's not part of Toyota production systems, which we have time I'll highlight, many people are well aware of the ACE. It's the waste of their human. The waste occurs when organizations separate the role of management from. In some organizations, management responsibility is planning, organizing, and controlling, and innovating the production process. The employee's role is to simply follow orders and execute the work as it's planned. By not engaging the frontline work, knowledge, and expertise, it is difficult to improve. This is due to the fact that people doing are the ones that are the most capable of identifying problems and often developing solutions for them. In that earlier slide, we talked about asset and the RCM and TPM as being where we are as the most advanced of how we've evolved, and about what TPM is about, involving everybody in the process. So that's a real quick down and dirty way of the 8 types of waste. And then we'll see you back in a few minutes, and I'll let some people in. They're still coming. But I do want to be appreciative of your time, and I'm going to be starting to share my screen again. So you should see the manufacturing process reliability screen back up again. Please say something in chat, or if not, and I will try to bear with the ongoing problem I'm having. So talked about Lean, going into Six Sigma. Now, some of you out there may be in different stages of Lean Six Sigma belts. I'm going to use maybe due to the process. For the CMRP, you don't necessarily know how to pull an analysis on Six Sigma, but understanding some of the concepts of it is what you're going to need to. And one of them is to know that there are 3.4 defects per million is what is defined as Six Sigma. Six Sigma addresses quality, consistencies, and effective systems design. It focuses on the ability for operational process to meet the customer's expectation. Think about the automobile assembly plant is designed to produce cars that meet the quality standard. But to ensure that these targets are met, quality control procedures are instituted to conform that the assembly processes are in control. Think about the medical procedures. The health clinics are designed to minimize infection. Six Sigma is often defined as a highly disciplined process that focuses on developing and delivering a near perfect products and services. It's evolved within the management philosophy. Its foundation is linked to statistical determinant. It's often used to measure how far output of an operational process deviates from perfection. The less deviation, the more acceptable the output. When it deviates too far, the process produces defects and an unacceptable outage. I'll try to explain that a little bit. 3.4 defects per million opportunity. That seems like a lot, right? Most organizations would go broke if every process was designed to ensure that they were less than 3.4 defects per million opportunity. The cost of achieving this quality level, near perfect result, would have many few organizations other than such as industries as medical, national security, nuclear power, and of course, air travel. As a result, most processes are designed in such a way to ensure that the output is in the range of around 4 Sigma quality. When considering quality, it's necessary to compare the process inherent quality from customers. You may have seen this, but it's going to make sense in a moment when I bring back another slide. But what you have here is 4 limits: lower control limit, upper control limit, lower specification limit, and upper specification. Quality is delivered when the capabilities of this process defined by the lower control limit and upper control limit fall within the expectations of the customers define what they design as being the lower specification and the upper specification. You see on here where you have your bell curve back. The distribution at the top represents a process variation. You can see that the small but substantial percent of outputs fall below the lower specification limit and the upper specification. Now, in this area here, it's saying that the specifications need to be broadened out, that we probably are experiencing a lot of rejects, and the specification of the customer is still being met. So this could lead to a possible redesign. The goal would be to reduce the variation of the process output so that the normal curve describes the variation within the output is well within the specification limits of the upper and the lower. What you would need to know for a CMRP is some of just the basic concepts of it. And think about it this way. Examples of Six Sigma design process. A restaurant deliver, this necessarily wouldn't be accurate, but a restaurant would deliver 3.4 defect meals per 1 million. Another example would be the hospital experiences fewer than 3.4 failures per million MRIs taken. An insurance company would expect that 3.4 errors would be processing automobile insurance claims, or the airlines of 3 late departures per million departures. Printer manufacturing experiences less than 3.4 defect printers per printed manufacturing. So these aren't necessarily realistic to them, but the idea is that 3.4 million defects per opportunity is something that I just like to get etched in your head is primarily what you would need to walk away from understanding what is Six Sigma and what is meant to drive out. It's drive out quality variability. So there is a process to Lean Six, and there are 5 steps to provide a systematic problem-solving methodology for moving Six Sigma projects from the initiation state to completion. This is where Lean plays a part into it, as far as pulling some of these tools out there. The sequential nature of these steps suggests following in one direction, however, revisiting these steps as they may be needed. I'll try to go through each other quickly. Defining what the real problem we face and how we can describe. It's how we know if we fixed it and we can close the project. Measure is to better determine the problem and what data we can have to support it. Analyze. This is the 3rd step, a focus on analyzing the data to better understand the problem. Further reveal its underlying cause and point to solution. This is where Lean tools plays a part within. And then, of course, the improve. Taking what we currently have and we want to make it better. Depending on the nature of the problem, this could be as simple as eliminating a step, purchasing new equipment, or as complex as redesigning or almost every step in the process. But the last step, and I can tell you this is the hardest, is the control. You're faced with stabilizing, monitoring, and controlling procedures to ensure the process output conforms to the expected performance level. At this step, the project closes with the establishment and implementations that you've got controls in place to ensure that what was defined early on completely been mitigated and your sponsors and your stakeholders are set. These are the 5 steps. Now, the last area I'm going to go through, and then I'm going to go through a little bit about the CMRP exam, in addition to different areas to familiarize yourself with as far as the manufacturing process reliability. In the earlier slide, I talk about total productive maintenance. You may or may not have seen this house here before, but you've got the different pillars. It's total productive maintenance, wherein the word total means total employee involvement, the total number of manufactured equipment in the factory, the total processes of the factory. Productive means generating and getting the most out of the set of inputs. And maintenance means the careful management and upkeep of the assets and equipment in the factory. TPM today may also stand for total productive management and even total perfect management. TPM its origins are back regarding the Toyota Motor Company in the late 1960s. Their suppliers had adapted this philosophy, and later was brought into the Toyota Motor Assembly. And in the 1970s, it had become popular throughout the Toyota Motor system, and it's performed. The backbone was what's famous called the TPS, or the Toyota Production System. If you're interested, there's many good readings on that, on how Toyota and the Toyota production systems have played parts in driving cultures and change within organizations. It's employee involvement. And if you look at this visual here, if you look at the original conditions of what you say is the life cycle, and when we get into business management and equipment reliability, we'll talk about terms like the bathtub curve or the process and failure rates. But if you had an original piece of equipment and without doing anything, you may naturally see forced deterioration. It loses its functionality. But when the theory of adding autonomy to it, which is a pillar of TPM, you will allow that piece of equipment, that component, whatever you'd be managing, to run its natural state. So it's natural deterioration. You incorporate inspection and you evolve, you restore deterioration, and you're creating longevity and creating more reliability, putting more planned maintenance into effect, and increasing the natural life cycle. And oh, by the way, when that happens, you create more reliability, sustainability, and profit. I'll try to go through these relatively quick. I do want to hold some time at the end for there are questions, and I do want to talk about the exams. But you're returning the equipment to reliable conditions through inspection. Cleaning machines, identify the needed repairs, tagging the equipment. Next is your focus on the elimination of the breakdown. To do that, you want to make sure you've got measurements. You're collecting the data, that OEE, or you've got a Six Sigma, an evaluation measurement process on it, and you're applying countermeasures. You're involved in the total organization, and you're moving through the different steps of cleaning, inspection, lubrication, working on fasteners, cleaning practices, visual and management, and just applying those tools and bringing the employees along with it. Through the understanding of different defects and prevention leads to the factory increased employee engagement and autonomy. Often this can be done through trainings, having operators responsible for some of the basic weekly, biweekly PMs, visual controls, lubrication points. Think about where the gas, water, energies are used. 5S process for around the equipment, doing more in time maintenance, preventive maintenance, and continue reviewing it. Ensure safety is also part of the program. Unlike other things, it's 100% involved. Just to talk real quickly, the Toyota production system describes the structure and consistency. Now I talk about the Toyota production system and the TPM. TPM is an evolution of what was the TPS. It manages, maintains, and improves the production activity. The production system is the knowledgeable bank of the company's manufacturing know-how captured in a permanent yet day-to-day deployment form to build quality and productivities in their operation. The manufacturing world had and heard the Japanese success within the QC circles, and otherwise known as the small group. It's been the backbone of what many automotive industry and others use today. A couple areas, and if you can, take a screenshot that will be beneficial for you, that if you can understand some of the concepts to it, will help you be successful on the CMRP are as follows. And we talked about the Six Sigma TPM, and we didn't touch on process flow charts, statistical process controls. You can not often argue that's leading into Six Sigma. The parameters, risk identification, that can be done through an FMEA or it could also be a Pareto. Root cause analysis, think about those fishbone examples. 5S, understanding what the 5S are, sort, set, shine, standardize, and sustain. I talked about Toyota production systems, the lean theory of zero defect, ISO, value stream maps, understanding management change, communication. This plays a part in leadership, manufacturing process reliability, and really in all aspects of the 5 pillars. Understand stakeholder management, how to make SMART goals, and then again on ISSO. So I'm going to jump around just a minute here because I want to get to the slide that I want to talk about. And I think now where I put it real quick. There you go. So a couple facts about the CMRP. You may or may not know this, but I'm going to go through them just as a there's 110 questions, multiple choice. Each test is 2.5 hours to complete with a 10-minute break halfway. Within those two sections, you do have the capabilities to go back for the first section and change your answers. But after break, that thing locks in and then it carries on to the second half. It does have to be completed at a test center. There's no pen or paper allowed. There is an even balance between the 5 pillars. However, a lot of them in conjunction with each other. Most acronyms are called out. The thing about the exam, it's not meant to have deceiving or trick questions, but it does want to test your knowledge on the subject. So there's no complex questions, but there is checking of the knowledge. So think about this. The test taker has an average of, if it's a 2.5 hour test, 110 questions, you have about 82 seconds per. I ran the math on this. The average read time of each question is about 11 seconds. And this is based on the examples that the SMRP gives out during their website. And also, having taken the test, I'm familiarized that there's no real long questions. So knowing that, it kind of gives you a little bit of ammunition to know that it's not an exam that I would feel that you wouldn't have enough time to answer each of the questions, or you need to worry about the time limit, which for me kind of eases myself to my awareness is that if I'm spending too much time on a question or not, because for this exam, there should be enough time in the allotted. I've never heard of anyone saying that didn't have enough. So some of the common practices you think about taking an exam is read more than once because you've got time, and think about how would SMRP want you to answer? Now, a lot of us got a lot of experience and could be maintenance or liability. Within that may not be some of the best practices or common practice. So think about how SMRP would always remove the obviously wrong answer. Look for strong language and remove it. Think about when they say the words must, will, absolute, can. Rarely is everything 100% certain. Remember death and taxes, and the idea is that those are the only two things that are really certain in life. So as you see those, be aware that it could be a question that is meant to distract or deter. And you can mark and review it. The other thing is look between the two longest answers. And the idea is a long answer could also put emphasis that's adding thought and want to distract, or it could be the emphasis of, it could be the correct answer. Correct answers often have verbs of the same tense and have nouns or verbs that, and then, often you go back to your first choice. One thing I will say is that I do sell a CMRP test simulator that's got 280 plus questions on. And I know when I was growing up, they always said that if you don't know, you can always choose C. I don't know this for fact, but it is a computerized system. And I can tell you the way my system works is that I randomize that each question will not always be the same one. So while the questions may be created in order, the computer randomizes it, and that debunks that theory that it could be C. So it's always best, if you're not sure, go with your first choice, try to eliminate those that fall with. All right, so I want to do a couple questions, and these are CMRP-like questions. And if you can, just put it in the chat. I'll try to go through. So question 1, a new plant manager just started her position as a widget manufacturer. She wants to increase operator involvement, common repair, or maintenance. What program would be best option to improve their current? Would it be implement employee planning immediately, perform an assessment on current PDM programs, launch an autonomous maintenance or TPM program, or start Six Sigma? If you can, just take a moment, put it in the chat. Okay, we're getting a lot of answers coming in here. Good. So the answer is C. And I said TPM at the end because we were talking about that today. Autonomous maintenance to provide your operators with the tools, including digital, always up-to-date work procedures. They need to perform maintenance tasks and on their own equipment. It emphasizes proactive and preventive. So good. Next question. What is the best option to why a factory would conduct a failure mode effects analysis? Is it A, to identify planning gaps? B, to use it as an onboarding project to new employees? C, to prevent the need for Six Sigma? Or D, to determine the likelihood of future failures? Put it in the chat. Okay. Good. And the answer is FMEA can help find possible or potential failure mode in a system and or thus cause and effect. Which of the following would be the best option to why maintenance department would perform a skills assessment? A, to score against other departments. B, to determine gaps and create an action plans to improve. C, to remove low-skilled technicians. D, cooperative initiative, the departments are required. Yes, the answer is B. To improve the skill gaps is the best option since good leadership is always trying to improve their work. We got 2 more. A team has been assembled to conduct a root cause analysis on a recent spike in the number of breakdowns. What tracking metric might be a leading indicator to look at first? Is it the OEE? A, B, the mean time to repair? C, mean time to failure? Or D, the cost of a breakdown? So the key word here is leading indicator. A key word that I mentioned is what we have: leading and lagging indicator. The overall equipment effectiveness is a lagging indicator. Mean time to failure would show a spike in the number of failures, while mean time to repair shows how long each repair took to complete. The cost of breakdown is just meant to be the QC code. it'll take you to my website where I do offer on-site and virtual training packages for your organization. And then also individuals will have workshops. But also if all don't fit your needs, certainly check out some of my books. And that being said, I guess I'll open the table out for if there's any questions or anything in the chat that you might have for me that I could answer at this point. Stop sharing. Okay. So if you see at the bottom of here, you can see where my LinkedIn is. And if there's other questions that come up, you can message me, and I feel free to help out anybody of those that got some questions on maintenance reliability or planning and schedules in general. I like talking about it, and be happy to help you if anybody has any questions or need some directions on where you might want to go. But I thank you for joining the call today. I apologize for technical hiccup. I normally don't have this problem with the Zoom, but thank you for bearing in. And I hope you enjoy the rest of your day or the rest of your evening, wherever you're calling from. And I hope to stay connected with you and feel free to. Okay. So with that, I wish you goodbye and thank you for attending.
Thanks, AW, for the great session.
Yes, sir. Thanks for coming again. Take care.